Hey guys. So the first thing is, what is blockchain? I know this video is titled Introduction to Solidity or Introduction to Writing Code for the Blockchain. But the point is, before you start writing the code for the blockchain, do you understand what it is? Do you understand why you are writing the code for it? So this video is just going to take the first 2 minutes to like break down why you want to write code in the first place for the blockchain. So the first question is, what is the blockchain basically? So we know that by definition of, or let me say by just general definition, a blockchain is just a ledger. So take it to be just a ledger. Is like an accounting book where you document debit and credit, let's use that word, where you document transactions that you've done, where you document transactions between one or more people, between one to one person, between one or more people, between many people to many people. So it's just a ledger, it's a book. Take it like a book where you document your transaction, you as a person, between people, between companies, between businesses. That is what a blockchain is. So it is that book. But in this case, it is a book that cannot be tampered with. Once you have written and documented something, it cannot be changed. That is the essence of it. So if you are fascinated by the fact that you want to create data that cannot be altered at any point in time, and you feel like, oh, okay, I'm creating this, and I believe that if I create this, I don't want it to change. Of course, if I need more information, I can always update it. But once I have written that data, it is impossible for me to delete that data. It is impossible for me to alter what I've done except updating it and adding more information. So if I'm to update the information, I need to write a new information to update the existing information. Now that's the beauty of it. Does that make sense? Now, interestingly, that is what the blockchain does, or that is what it is. It's just like that book where you can write, but you cannot delete. Exactly. You can only write, you can only update, right? And every update also is a new information, is a new data written to the ledger, which in this case is the blockchain. So technically, let's leave it at that. 2 minutes, I said, we just talk about what the blockchain is. So that is basically what it is. So what is the blockchain? I've explained that now. So now, before we get into the writing of the code, so why do we need to write code for the blockchain itself? Now, the reason why we need that is because you want to actually program something that works on its own. So let's say, like I said, now we have a blockchain being a ledger where you document transactions between yourself and other people, or between yourself and your business, between yourself and your clients, between yourself and your business partners. Basically, it's just a book where you document transactions, right? So when you want to document that transaction, you don't want to be going there every single time to write, okay, this is what I'm doing. You want to have like a program, because now we are in digital world, right? Everybody have programs that does one or two things for you. You have chat applications that help you to connect to the world, everybody across the nations of the earth. You have different software, different applications that help you to simplify your workflow,
It's 16 hours.
simplify your life. You have different application and software that help you to simplify your workflow, simplify your life, simplify every single thing you do, right? And so in that regard also, you want to actually have programs that is able to perform those transactions and make life easy for you, so you don't need to do it all the time. So you just want to, like, at the click of a button, click something and something happens. Probably you want it to be like, okay, if I click a button, I pay all my stuff with just the click of one button, not having to do it manually. So in that case, you need a program. That means you need to write code. That's the only way you can have a program. So in this case now, what do we need to do? We need to learn how to write a program. So that is why this video exists, and that is why I'm writing this video. So 4 minutes into this video, I've already explained what a blockchain is and why we need to write code for the blockchain. So let's jump into the code itself. So the first thing is this. What do I use to write the code, right? How do I write the code is the first thing. So there are certain questions we need to ask ourselves. Let me try to write this. But okay, there's no need. So the first question I'm going to ask is, why do I need to write the code? Now, the reason why I need to write the code I've explained. So how do I write the code now is the next question. So the answer to the question is, I need to use a programming language, right? We are familiar with languages like JavaScript, like TypeScript, like Python, like, C++, C, Java, Rust, Golang, Z. all of those languages, they are programming languages that we use to create applications, web apps, mobile applications. Do you understand? So in this case now, we want to write applications for the blockchain. So how do we do that? We need a language called Solidity, which is like the most popular one. There are other languages to like create applications for the blockchain, but the most popular one is Solidity. Now I'm going to call it, I'm just going to like show you guys what it is. Now it's just a programming language for EVM basically. So it's not the only language to write programs for the blockchain. Of course, we have different type of blockchains, right? We have EVM chains, we have the SVM chain for Solana, we have other chains like Aptos that use Rust and have their own programming language called Move. So we have a lot of these languages. So I have a dedicated video where I'm going to like talk about all these languages, programming, all these blockchains, not the languages now, and their languages itself. So where we'll break down all of those things. I have that already in the works, so I'll release that, and once I release that, it's going to be linked to this video whenever you're watching, probably by the time this comes out. So let's just get into this stuff. So what I'm trying to say now is that what we need to do is, you have this language called Solidity. It's a programming language that enables you to write programs that runs on the Ethereum blockchain. Now the Ethereum blockchain is basically a blockchain that allows you to write programs. It is embedded at the core of the blockchain, allows you to write programs called dApps, right? So in this case now, we are trying to write a program and we require a language called Solidity. I'll talk more about Solidity in that video, so I'm going to link that to this video so you can watch it. And also I'm going to talk about the different type of blockchains, but in this case, just take it that we are writing this for this video is going to be for Ethereum, and that's for the EVM. So Solidity is the language you'll be considering. There are other languages, like I said, there's Rust for that blockchains, but let's just focus on the EVM chains for now. So something called Solidity. So we already understand how do we program it. What do we need for the program? The first thing we need is what? We need Solidity. What is the next thing we need? Good question. The next thing we need is, where can we write Solidity, and what do we need to write it to be able to deploy it? So that's a simple question. So what we need for a start, there are many ways to do that. There's something called ADAT, and ADAT is just like a it's an environment. Yes, so it's an environment where you can write your Solidity programs, compile it, run it, and deploy it to any blockchain you want of your choice, right? So it's an environment that allows you to do that. So you're familiar with environments like okay, let me just skip it at that, right? It's an environment for writing your Solidity contracts, right, and deploying to any blockchain of your choice. There's something also we called Foundry. Now, Foundry is also an environment like that. Yeah. So let me say Solidity, since they are different Foundry. Yeah. So is a development toolchain similar to what you have for ADAT. So they are both environments that allow you to write, right? So they are development frameworks. So ADAT is a development framework, Foundry is a development framework. But the difference between that is that Foundry allows you to write everything you do with Solidity. ADAT allows you to write with both JavaScript and Solidity. Don't worry, we'll talk about that in another video. Let's not go into that one. So basically, what we need to understand is, what do we now use? Now, there's something else called Remix, which is this remix.ethereum.org. Now, before I go into remix.ethereum.org, Remix Ethereum, the first thing I'm going to show, Remix Ethereum is also a development environment where you can write your Solidity programs. But the interesting thing about this is that you can write it online, deploy everything online, so you don't need to like install anything locally. So it works online and you can deploy online, save online, send to GitHub from the online environment. Does that make sense? So basically that's what this is all about. So we are going to be making use of Remix for the sake of this video, because this is just like an intro. So to access Remix, I'm going to close this and open it again, leave the site. I'm going to go to the official website, is remix.ethereum.org. That is the official website for Remix IDE. So this is what I want. This is how the interface looks like. You can configure it if you want. There's this email, there's this theme I always like to use, not this, yeah, this one. I love this theme better than the first one, so I'm just going to stick to this one. And yeah, So this is how it looks like. So this is the home interface. It's a bit congested. Yeah, it can be terrible sometimes. So let me just close this. Now this is what you have. So the first thing we're going to do is I'm going to show you like the structure of a contract first of all. But in this video, like I just want to show you okay what it is, right? So this is what Solidity looks like. So basically this is what Solidity looks like. If let me zoom this in a bit and you see this here. Now let me reduce this and just increase the yeah. So this is it. So this is how Solidity looks like, right? It has this syntaxes. So this, let me just explain this. The first thing you need to understand is we have this thing by the left here called storage dot sol. Now this is just a name. It's just like you have a name given to any file, right? Or any yeah, let me just say a file or a document. Like you have your Microsoft Word document or Excel sheet, all of them have their extensions and their names. So basically this is what this is also. So in this case now you have a file name given to this contract that you've written. Now this contract is meant to do something, right? So you know what it's meant to do. You have an idea of what you want it to do. So you have a program in mind that, oh, I want to write a program that does this on this blockchain. So you have the logic in your head. What do you want to do? Oh, I want it to do this and this and this. That's the first thing. Now, once you have that in your mind, you create a new file. So let's say I want to write a program that, so there are different icons here. If you over on this folder here, don't worry, I'll talk about this like in another video extensively, how to use Remix to understand every single thing that happens in Remix, how to use it and all the stuffs, all the icons and how they work. But I'm talking about Solidity here, right? So let's understand Solidity. So the first thing you need to understand is how do you do this? So the first thing you need is when you click this create a new file, I click on this, I give it a name. So let's say I want to create a program to pay. Should I say pay or let me say salary? Yeah, nice. So let me say salaries. I can just call it salary.sol. Now, salary is the name of the file, right? So I give the file a name called salary. Now, this file now that I'm talking about is where my contract logic, that's my program that I want to deploy to the blockchain, will be called, right? So I'm going to call it salary because I want it to handle the salary, payment of salary for my staffs. That's what I want it to be. Then I'll call it salary.sol. Now, .sol in this case means how do I identify this file? Imagine if I have multiple salary. Let's say I have a file, a document called salary, Microsoft Word document. I have a Google Sheet document, a Microsoft Excel sheet document also called salary. How do I differentiate between them? So I have an extension. There's something we call an extension in files called .sol. Now this .sol is simply identifying it to be a Solidity contract. That is it. So once I'm done with that, I'll just click the enter button on my keyboard. And once I do that, you can see that there's a new file automatically here. Now, remember I'm using Remix. Remix is an online environment for me to write my programs using Solidity for Ethereum blockchain. Very simple. So since I have this, the first thing I need to understand is I've created the file, right? What do I need first of all? Now, before I start writing any code, I don't want to write the code yet. I want to show you an example of an existing code so you can understand what we need. So the first thing we need in this case is we need something called an identifier for this contract. Now, it's just a convention. It's not something that you need to keep, like, I mean, you don't need to like know the syntax top of your head, but you should, because you should know that the first thing you need for every smart contract is the identifier. So first thing I'm going to do is I'm going to write an xpdx. Now you can see that it's basically like the same format. So like I said, you don't need to remember it. So I'll just go to an existing contract and copy this and come back here and paste this. Now what this means is that I am identifying this contract with a license, right? So these things you see at the end of this place can be different things. This is a GPL license. I can have an MIT license also, but let's not go into that. I'll probably explain that more. I don't want to like dive into it because talking about this also is like its own stuff. So let's not deviate too much. So basically what I want to explain here is that you need just to realize that you need to have this license identifier for every contract you write. Right? So every program you are trying to deploy to the blockchain, for Ethereum, for Solidity, you need this. It doesn't apply to other programming languages or other blockchains, but for Solidity and for Solidity compatible blockchains, you need this guy, this line of code. very needed. So just remember that you need the license identifier. That's all. I'll talk about that in another video. I'll probably share that also very soon. So the next thing I need to have is, once I remember that I need identifier, I need to go back to this and see there's something called pragma. Now, pragma is not a new term it's not new to Solidity. For those that are familiar with other programming languages, probably are coming from a language like C++, you'll be familiar with the word pragma already. Pragma is now you can see this, see what I was trying to explain. You can see that there's another identifier here. So I could probably use any of the two. There's GPL license and there's MIT license. There are a lot of other licenses you can use, but let's stick to the one we copied. Or in this case, let's change ours to MIT license, like I was trying to explain. Now, the pragma here is a term, and this is compulsory. Just like this is compulsory to remember, I said so. You also have this at the beginning of all your smart contracts. You need to have these two, the license identifier and the pragma version. Now, the pragma simply means it's let me just leave it that it's a keyword, right? Pragma has its meaning, but for the case of this video, I don't want to go deep into technical stuff. I'm just trying to introduce you to Solidity. Pragma has its meaning. And the meaning of pragma in this case simply means you are trying to use it to specify. It's like it's a very unique keyword that is useful to the compiler. The compiler in this case is the Solidity compiler that you use to specify the version that you want to run this program with. Just understand it that way. So pragma is a compulsory keyword. It's a compulsory part of your smart contract, so you need to write it as pragma. Pragma is a very unique keyword that the compiler requires to know the version it's going to use for Solidity. Now, why do we need a version for Solidity? There's a lot of stories to this, right? Blockchain is very, very diverse, so there's a lot of story to everything. But what you need to understand is that Solidity has different versions. There's version 5, version 4, version 6, version 7, version 8, version 9, and version 1 currently. So what we are going to deal with now is we have version 0.8. Let's just say we want to use 0.8. Now let's go back to this one we have here before, which is the storage. You can see that there's Pragma Solidity version 0.8.2. that means greater than or equal to 0.8.2, less than 0.9.0. But like I said, don't let us bother about this for now. So I'm going to go back to this place and say 0.08.19. I like using 19. I just like using it. So I'm going to use this thing at this place. We will talk about this eventually. So just know that this is important. In fact, we can just copy this, right, and just paste it inside here. It makes no difference, literally. As long as you specify Pragma Solidity, you can use any version you want. But just make sure that the version you use also makes it compatible, or the version you use is compatible with the code you write. That's literally what is important in this case. So I'm just going to copy what I have from this example I'm trying to use to explain, right? So now the first two things we've explained here is what? We have the license identifier. The second thing is what? We have the pragma. Very good. So we are already writing our smart contract. So these two things are just like useful for the compiler. That is what it is. Useful for the compiler and for the license of this code. So now let's go into the proper contract program logic. What's the first thing we need? The first thing we need is what? We are trying to say this is a contract. So I'm going to say this is a contract. So the first thing I need for my contract, now this is where the logic of my contract actually starts. Now you can see this is auto completion. So I'm not going to use the auto completion because I'm not really going to be writing code. I just want to like show you the syntax and semantics of a smart contract. So not for code. We will write code eventually in other videos just to show you how it works. So the first thing we need to understand here is we have the contract. Right, the contract is also a keyword. You can see that every keyword here has the color blue, right? So anywhere you see color blue, it simply means what? It's a keyword and it is useful for the compiler. Very simple. Like, it's that simple to understand. Once you see that, you know that, oh yes, this is a keyword that is useful for the compiler. You can notice from here, you can see blue, 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 blue. Do you get the point? Yes. So we are still going to write much more advanced contract and you see blue everywhere. So whenever you see a blue colored word, right, in your Solidity contract, it simply means what? It is useful for the compiler. So like I said, remember we need the identifier and we need what? The pragma. So what's the next thing that we need in this case? We need the key contract what? Keyword. Please don't forget that the contract keyword is important. Why? Because this is where you're actually specifying to the compiler that compiles this code that, oh yes, now this is where my contract logic starts from. What do I mean by that? This is where whatever is going to undo whatever this program will need to do, whatever logic is going to need to run is going to start from. These are just formalities, right? Remember that. But this is the beginning of your contract. This contract keyword is very needed. You can't have your contract without the contract keyword. Please note that. So after writing the contract keyword, the next thing you need to do is give your contract a name. Now, this name can be anything you want. I can name it Mayowa. That's my name. I can also name it Salary, which is the name of the program we are trying to create. So what I need to do next is, after I've written the contract and the name of the contract, what do I need to do next? I have a curly bracket. Now, this curly bracket here simply means this is the beginning. Now, this first one you see here, this first one that is to the left curly bracket that you see here, the curly braces, means that this is where the logic, everything that is inside this one, this opening and closing braces, is the logic of my contract. So it simply means if I have a contract inside a called contract salary, this contract here, whatever is inside this opening and closing braces, we only work for this contract salary. Whatever is inside of this opening and closing braces for what payment is going to only work for what the payment contract. Don't worry, we'll do more of this eventually in another video. So let's just focus on this. So that means since we already understand the salary, what's the next thing to do? Let me remove this. We are not talking about multiple contracts yet. The first thing I'm going to talk about is, oh yes, I have a salary, right? I want to write a logic to pay my staff. So what do I need to do for the logic? I need to have like an amount I want to pay. So for that, I'm going to have something. I will explain this. Don't worry. I don't want this video to be too long. It's getting too long already for my liking. But then let me just use this and say this is the logic. Public salary, 10 ether. There's a lot of things that happens. Get salary. I'm just trying to show you like the skeleton of what this contract might look like. Set salary, transfer salary, all of those things can happen. Now this is not like the actual logic, I'm just using to show examples. So in fact, let me do this. I'm going to remove everything inside of this place and let it just be what I have. So this is what your smart contract looks like. Once you can get to this point, you have started your journey to writing smart contract. Basically, if you understand that you need a license, you need Pragma, Solidity, and the version of the Solidity you are trying to run. You understand that you need a contract keyword, the name of your contract that identifies your contract, uniquely identifies your contract, and then you need a curly bracket that encapsulates the logic of your contract. And then whatever you now write inside of this place, the jargon, the normal thing, the reasonable, the bugs, everything you write inside of here then becomes what? Becomes the logic of your contract, of your program that you want, that you expect to run on the blockchain. So yes, I'm going to end this video here because I don't want to go too deep into this. We have a lot of things to cover little by little by little before we bring everything together to become one smart contract, and then we deploy that contract on chain. But before then, you already understand. I say you need a license. You can always copy this to from any existing contract, so you don't need to always keep it to your head. And the next thing we have, oh, I have a low battery already, is you need a contract name, contract, and the name. You need the contract keyword and the name of the contract and the opening and closing bracket. So I hope you've learned something from this video. In the next video, I'm going to cover how to start writing the contract. I'm going to have a dedicated video for explaining this also, but I feel like that's not important right now. Let's dive into the most important aspect of things like writing variables, right? And writing things like name, like this kind of thing. But I'll talk about that in another video. So now let's stop here and watch out for that video. So if you want to get that video and get notified when it drops, you can subscribe to this channel, and I'll really appreciate if you like the video so I can know I'm really doing what is right, what makes sense with these videos. And if there's a way I can improve on it, just feel free to drop the comments in the comment section. So that will really help me a long way to like know what to do, know how to make changes, right? I hope you understand what I'm saying. So yeah, basically, so this is what it is. So I'm going to continue from this same code in the next video so that we can follow along and see what we are trying to do. Now, like I said, this is just going to be like an explanation. It's not going to contain crazy code. It's just going to be very simple thing that you can follow, understand how it works. Then you can start thinking of your own crazy logic when you are done with this series and start writing your own smart contracts. So basically, this is where we stop in this video. Thank you very much for watching. Catch you guys in the next one. Bye for now.